All right, this is the review for the second part of the quadratics. We had a first test before Thanksgiving break, and then this will be the test that follows up. A couple of the topics at the beginning are things that were on the first test, but we're going to go through them again just to make sure that we're really efficient and strong on these topics, or as strong as we can be with them. The beginning part that I have on the review, these equations I wanted you to be able to solve using quadratic formula. So you may be able to factor them, but the intention is to actually practice quadratic formula. The first that I wrote, it should say equals 0. That's just something I neglected to do on the review. But if you didn't have like an equal, then you can't actually solve it. So the idea was that it's supposed to be a 0. What you should start with when you're going to do quadratic formula is to identify your A, B, and your C values, which I went ahead and listed over here. Then once it all gets plugged into, it's going to look like this. So I'm going to save a little bit of time in the video of just letting you see already what it looks like when it's filled in. The one thing that I would point out about it is that when I plug in the B values into the B squared portion of it, I always go ahead and just square that myself. The thing is that if the B value is a negative, that sometimes we just don't quite do that operation right, even though we know how it's supposed to work. So anytime something is squared, it's going to be positive. So if I had a 5 or a negative 5, I would just write in a positive 25, and then I know that that part's going to be fine afterwards. All right, once you work out all of this, it is going to reduce the discriminant down to a 9, which happens to be a perfect square. So there's going to be some of these cases that are nice, and then some of them that are not quite as nice. The square root of 9 is a 3, so after this step, you're going to have the negative 5 plus or minus a 3 over an 8. Okay, and then because these don't have any radicals in it, we definitely want you to split up the answers so that you can see both of them. We'll have the negative 5 plus the 3, which is going to give you negative 2. So you have negative 2 over 8. You will also get the answer, which I'll reduce that in a minute. You'll also get the answer that when you subtract the 3, you get a negative 8. So you have negative 8 over 8. So with these answers reduced, you're going to get a negative 1/4. You're also going to get a negative 1. And those are the answers that we want. So it could be done by factoring by parts with a 4, but just do quadratic formula. That's what we want on the test. All right, the question that is next to it. You do have to move the negative 5x over, which is going to show up as a positive 5x, and then you've got your 0 over there. I've identified my A, B, and my C, so the B value is going to be a positive 5 when it moves over to the other side. This is everything plugged in. There's your B squared, there's your 4 times A, and then times the C. And once I did all the multiplying here, I got a 36, which gives me a discriminant of negative 11. Now 11 is not a perfect square, so not much you can do with that. But if you do have a negative, we're going to want you to move that to the outside as the I. So square root of negative 1 gives you the I. So not really much changes once you put all this together, except that we want that negative out front as the I value. All right, for problem number 2. Okay, for problem number 2, one, I do have a little bit of a typo here. You're not going to be able to plot 5 coordinates. I had copied and pasted this from the last review and just tried to change with the problem. You're not going to be able to get 5 points on the grid that I gave you, but 3 points will work out fine, and for the test you'll still be able to do 3 points. Okay, so here's an equation you get. This is in vertex form, and we want to make a graph of it, and we want to list all the items that you can see over here to the side. Now, first off, the vertex. It's going to be the opposite of that x, the number behind the x, and then you're going to take this number as itself. So the vertex is going to be negative 3 and 5, which I went ahead and already plotted there. You can see that dot. With that done, you actually also have your axis of symmetry. Okay, so your axis of symmetry is just going to be this vertical line that's here, and for that, the equation is going to be a line. It's not a coordinate, so you're just going to write x equals negative 3. It's exactly the same thing that's right there. So once you've got your vertex, you really just have your axis of symmetry, and it's like a 2-for-1 that you get there. All right, let's see. The Y-intercept, to get that, well, sometimes it shows up in the graph, so let me work with the graph, and then if it does show up, then I'll just steal that pointer, or then I'll talk about how you would do that. Okay, so the main thing about this graph as you're going to build away from the vertex is that you've got the 1/5 as your A value. Okay, and any point I have a fractional number as my A value, I like to build this table of the squared numbers. So I'll just list 1 through 5, and then these are all the numbers 1 through 5 being squared. Okay, and by the time you get up to about 5, most likely you'll have the right numbers that you can use to work with this A value. Okay, now the way you can interpret these is from the vertex, so for the regular parent function, or if it had an A value of 1, it just says from that point you could go over 1 up 1, but you could also maybe go over 3 up 9. So from the vertex I could go over 3 and then up 9 units. Okay, but since we have an A value, what you want to do is multiply that A by one of these squares. Okay, it's not going to multiply nice by the 1, the 4, the 9, the 16, but eventually when you get to the 25, you can easily multiply the 1/5 by 25, and that's going to give you a 5. 25 divided by 5 is 5. So I'm going to take this pattern of how I would normally move, and with the adjustment, I'm going to get this. It's going to say that I would move to the left or right 5, but I'd also go up 5 units to get to my next point. So if I go to the vertex, I can move over 5, go up 5, and that's going to give you a point right here, which is good for us because it's actually one of your X-intercepts. Then you do the other side as well, which ends up off the chart on the graph that I'd given you. But you're not going to get any nice points that are in between here. That actually just is the first really convenient point that you're going to get. So like I said at the top, you are going to have to change the instruction so that you're just plotting 3 points. You're not going to get 5 points out of that. All right, so the Y-intercept, don't make any assumptions that it's at a spot. I just mentioned here that it isn't at an actual true location, so we'll go about that in a minute. But when it did get graphed, you ended up noticing where it shows up for the x-axis. So the x-intercepts are going to be, let's see, at 2, 0 and at negative 8, 0. Okay, and you don't need to do any factoring anything for that. It just sort of worked out. All right, now the y-intercept, to get that, because it's not at a nice spot, what you're going to do is you can think of it as a coordinate and the x value being a 0. So if I ever plug a 0 into the equation, I have 1/5 multiplied by 3 squared minus 5. Okay, now this is going to be a 9, and 9 times 1/5 isn't anything really great. It's going to give you just 9/5, and we do need to subtract the 5 from it. So if you're pretty good with your fractions, what we'll do, we'll change the 5 into a fraction with the denominator 5. So we're going to end up with 9/5. We're going to subtract what will be 25/5. That's the same thing as 5 with a denominator 5. So that way when you subtract them, you can just subtract the top and then you keep the 5 on the bottom, and that's going to give you, it's going to give you negative 16/5 for that one. So not a nice number, but it is what it is, and that's where it ends up. That's also the same thing as about it's about negative 3 and just a little bit more. Okay, so my graph isn't quite right. Go under there, but for the purpose of the test, you'll only need to graph the actual conveniently good points. Okay, the tough stuff, all that's easy. The tough stuff is that focus and directrix. The graph, we can see, opens up like that. The focus is going to be on that axis of symmetry, somewhere around here. The directrix is going to be a line that's underneath it. So for the focus, we already know that it has to be at a negative 3 and something. Okay, it's the same thing as axis symmetry and vertex and all of that. All right, now where is it with respect to the vertex, though, like vertically, up and down? That's going to come down to your p-value. Now recall that your p-value, this is an equation I gave for the last review, the p-value is equivalent to 1 divided by 4 times a, where your a value is the 1/5. So when I calculate this part here, looks a little bit goofy, but you can have a 4/5 in the denominator, which means that you can actually flip it over and just call it 5/4. That is also the same thing, which you can find convenient here, the same thing as 1.25. So that being the value P, it tells you the distance from the vertex up or down that we have to go for the focus and the directrix. So for the focus, you have to go up a 1.25. Okay, when you move up, see this is at -5. When you move up from -5, 1.25, that's going to take you to a -3.75. Okay, and then for the directrix, that's going to be a horizontal line, which will just take a 1.25 and go down that amount from -5, so it's at -6.25. This, in my opinion, this is a little bit of a harder part, but that's what it is. You take your A value, you do these things. This is the worst it could look like if you have a fraction, but once you have that fraction, you're going to add and subtract from your Y value of your vertex. All right, the sun here, somewhat in the way, keeps moving on me too. Okay, 3 and 4, these are going to be much easier problems. This will go quick. If you have a vertex and a point and you're asked to write an equation, you should use vertex form. It's literally the most obvious thing that you should be doing. Okay, now, so from the vertex, like what we saw before, you're going to have an opposite value for the x as it would look in the equation, and the y value of the vertex, it shows up as it is. Okay, so in the equation, instead of a -2 here, you're going to have a +2. Then you're going to have the +8 or the +8. That's at the end. That would be the main first step. All right, after that step, you're going to take the coordinate that's provided for you and you're going to plug that in for x and y. Okay, so the y value has to be 20 when x is 2. Then we just solve for a. Okay, so we got the 20. This is going to be 4 squared, which is 16, so 16a plus 8. What we'll do is subtract the 8 from each side. That's going to give you 12 is equal to 16a. And when you divide by 16, we can just reduce that down to 3/4. So that's your a value. Then you just piece everything back together. Okay, so you got the 3/4 for the a, you had the x plus 2 that we already had, and you got the +8. And that's it. Overall, that question should not take you that long. Pretty much about as long as I actually spent going through it. All right, 4. If you have x-intercepts in another point, you should use intercept form. That's going to have the a value out front, the 2 sets of parentheses where we're going to get our intercepts in. The intercepts do go in as their opposite. That's going to give you a +3 and a -8. And again, we're just looking for the a value. So if we take the coordinate that's provided for us, okay, if we take the coordinate that was provided for us, we can plug it in, and it shouldn't take too long to get this. That is going to be a 2. Let's see what we got here. We got a times a 2. This is going to be a -9. So together that's -18. You have 8 is equal to -18a. We divide by -18. Reduce it as we can, which is going to be just by 2. So you're going to get a -4/9 as your a value. Then you just piece everything back together. You're not going to have to plug anything into this. So if you don't have a nice looking fraction, it's okay. Okay, that'll conclude that one. All right, then the last one for this video, the 3 coordinates, using them to write a standard form quadratic. Most of the work I've already prepped here, so you don't have to worry about watching me write it. I'll just talk about the stuff. Each of the coordinates you're going to use to build an equation, like I'll just talk about the first one here. You take the 18 as the y value. The -2 is going to go in. Maybe I should write this down for you. Our template looks like that. Okay, so the -2 is going to go in for the x squared, which becomes a +4, so I have a 4a. The -2 goes in for this x, which is going to give you, well, just -2 times b, so -2b, then you have a c. You do the same thing for all the rest of them, and you'll get these equations. All right, then what we're going to do is start eliminating a variable. The easiest to get rid of here is going to be your c value. Okay, so what I wrote off to the side here is if I subtract the second equation from the first equation, I can get rid of the c value when I do the c minus c. Now I chose the order of subtracting the second equation from the first because of the size of the numbers. Like I can take 18 and subtract 6 to get a 12. I can take the 4, subtract 1 to get 3. Here it doesn't turn out as nice, but you have negative 2b minus 1b is going to give you negative 3b, and of course your c's will subtract and disappear. But it kept most of it as the positives. Okay, then I do another pair, which I decided to go with the second and the third. Again, subtract the second from the third one, because the 20 is bigger than the 6. They subtract to give you 22. They subtract to give you 8. That's going to subtract to give you 2b, and of course the c's will cancel. From there, we take these two equations and we build another little system which just uses the a and the b values. We think about how we'll cancel these out. The easiest, I think, is going to be the b values. It'll just keep the numbers a little bit smaller. If the first equation is multiplied by 2, that's going to give you negative 6. The second equation by 3 is going to give you a positive 6, and then that'll cancel out your b values. Okay, so that's going to give you a 24 is equal to 6a minus 6b. You're also going to get 66 is equal to 24a plus 6b. When they add, it's going to give you, that'd be 80 plus another 10, so we get 90. These will add together to give you 30. That cancels out, and very quickly we get a is 3. Now your b value, you could just go back to any of these equations. If a is 3, let's do this one. If a is 3, you're going to get 24. Okay, and then 24, we need to subtract something to get down to 22. So this needs to be a minus 2 altogether. And since you already got the 2, that means that b is going to be a negative 1. So there's b. Then to get c, you go back to any of the equations that you want. Probably the second one because it's got the smallest numbers. Let's see, the a value is a 3, the b is a negative 1, so 3 minus 1 is going to give you a 2. Okay, so that's all 2. And c needs to be the number that when you add it onto 2 is going to give you 6, so that'll give you a 4. Okay, and then what we should do is check them all out for another one just to make sure everything's good, and I'll do that over here. Okay, so the question is, does 18 equal 4 times 3 minus 2 times negative 1 plus 4? Well, that's going to give you 12. That's going to become a plus 2. So you're at 14 plus 4 is going to give you a total of 18. So we're all good. Then don't forget to put it all together. And that's your equation. That'll also include this video, or conclude this video. We'll pick up the next one a little bit later with problem 6, which begins with the inequalities.